Welcome to ZoomInData, your go-to channel for in-depth Azure Cloud, Serverless, and modern development interview preparation. In this video, we dive deep into the top 25 Azure Functions Event Hubs triggers interview questions for 2026. Perfect for developers, architects, and anyone preparing for AZ-204 certification or building high-throughput, streaming event-driven serverless applications. We cover Event Hubs trigger fundamentals, consumer groups, checkpointing, partition handling, batch processing, scaling, retry behavior, debugging, security, monitoring, testing, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is an Event Hubs trigger in Azure Functions? An Event Hubs trigger is an event-driven trigger that automatically invokes a function whenever new events arrive in an Azure Event Hubs stream or partition. It enables real-time, high-throughput processing of telemetry, logs, IoT data, or streaming events with massive scale and low latency. Built on the event processor host pattern, it automatically manages checkpointing, partitioning, and load balancing across instances. Ideal for scenarios requiring ordered processing of large event volumes from multiple producers, IoT devices, applications, logs. 2. How does Event Hubs trigger differ from queue trigger? Event Hubs trigger is designed for high-throughput streaming, millions of events per second, with partitioned, ordered delivery. Queue trigger focuses on simple message queuing. Event Hubs supports checkpointing and multiple consumer groups. Queue trigger uses visibility timeout and dequeue count for retry. Event Hubs trigger processes events in batches per partition. Queue trigger processes messages individually or in batches with simpler scaling. Event Hubs is optimized for telemetry and streaming. Queue trigger is better for task queues and workflow decoupling. 3. Explain the event processor and checkpointing mechanism. Event processor, underlying event processor host, coordinates event processing across partitions, ensuring each partition is handled by only one instance at a time. Checkpointing periodically saves the last successfully processed event offset per partition to Azure Storage, default Azure WebJobs storage. On restart or scale out, processing resumes from the last checkpoint, preventing data loss or duplication. Lease management handles partition ownership. Lease renewal failures trigger rebalancing across instances. 4. How do you configure Event Hub connection string? Connection string configured via app setting, e.g., Event Hub connection, with full Event Hubs namespace connection string or managed identity. Supports shared access policies, send, listen, or managed identities for secure, keyless access. Multiple Event Hubs can use named connections, e.g., My Event Hub connection. Key vault references supported for secure storage of connection strings. 5. What is the role of consumer group in Event Hubs triggers? Consumer group is a named view of the Event Hub stream allowing independent processing by different applications or function instances. Each function app should use a unique consumer group to avoid checkpoint conflicts with other consumers. Default, $default, group shared across applications. Custom groups recommended for isolation. Multiple function apps can consume the same Event Hub using different consumer groups. 6. How do you handle partition processing? Event Hubs trigger automatically distributes partitions across scaled instances for parallel processing. Each instance owns one or more partitions via lease mechanism. Partition ownership rebalanced on scale events. Processing order guaranteed per partition. Events in order within partition. Use partition key when publishing to control distribution and ordering requirements. 7. Explain batch processing in Event Hub's triggers. Event Hub's trigger processes events in batches per partition. Batch size configurable via max batch size, default 64. Function receives enumerable less than event data greater than or array of events for batch processing. Batch checkpointing occurs after successful processing of entire batch. Higher batch size improves throughput but increases memory usage and latency on failure. 8. What is the max batch size setting? Max batch size configured via max batch size in function. JSON or Event Hub trigger attribute, default 64 events. Higher values improve throughput for large event volumes. Lower values reduce latency and memory pressure. Limited by Event Hub's max message size, 1 MB, and function memory allocation. Recommended tuning, 32 to 256 depending on event size and processing complexity. 9. How do you handle event ordering per partition? Event Hubs guarantees strict ordering within a single partition. Events arrive in publish order. Use partition key when publishing to route related events to same partition for ordering. Process events sequentially within function code for per partition ordering. No global ordering across partitions. Use sequence numbers or timestamps for cross-partition correlation. 10. Explain checkpoint storage and lease management. Checkpoint storage saves the last processed offset per partition in Azure storage table named Azure WebJobs Event Hub. Lease management assigns partition ownership to instances and lease renewal occurs periodically. Lease loss, such as instance failure, triggers rebalancing and ownership transfer to another instance. Configuration is available via host. JSON Event Hub section for checkpoint batch size and lease renewal interval. 11. How do you scale Event Hub's triggers? Event Hub's trigger scales out based on event backlog and partition count, where more partitions allow more parallel instances. Multiple instances process different partitions concurrently and scale controller adds instances as needed. Premium plan pre-warmed instances reduce scaling latency for bursty streams. Throughput units in the Event Hub's namespace limit overall ingestion and scaling potential. 12. What is the difference between Event Hubs and Kafka triggers? Event Hub's trigger uses native Azure Event Hubs protocol, while Kafka trigger uses Kafka protocol through the Event Hub's Kafka endpoint. Event Hub's trigger supports checkpointing via Azure Storage, while Kafka trigger uses Kafka Consumer Group offset management. Event Hubs offers better Azure integration, while Kafka trigger enables compatibility with Kafka clients. Both provide high throughput streaming, but Event Hub's trigger is more tightly integrated with the Azure ecosystem. 13. How do you handle large event payloads? Event Hubs supports up to 1 MB per event in the standard tier or 100 MB in the premium tier. Use blob reference pattern for larger payloads. Store large data in blob storage and pass blob reference such as URL or shared access signature in the event payload. The function downloads from blob storage using the reference in event data. Compress event data or batch multiple small events to stay within size limits. 14. Explain Event Hub's trigger in premium plan. Premium plan maintains pre-warmed instances, eliminating cold start latency for Event Hub's triggers. Supports unbounded execution duration and higher memory allocation. Virtual network integration and private endpoints are available for secure streaming. Better suited for latency-sensitive or high concurrency streaming workloads. 15. How do you debug Event Hub's triggers locally? Use Azure Event Hub's emulator for local development or a real Event Hub's namespace. Send test events using Event Hub's software development kit or Azure Portal test event feature. Run the function using func start, and breakpoints will be hit in the debugger. Logstream captures event payload, partition information, and processing flow. 16. What happens if checkpointing fails? Checkpoint failure prevents progress tracking, and processing may restart from the last successful checkpoint. Lease renewal failure triggers rebalancing, and a new instance takes over the partition. This can result in potential duplicate processing if checkpoint is not committed before failure. Implement idempotency in function code to handle possible duplicates safely. 17. How do you configure starting position for processing? Starting position is configured using initial offset options such as from start, from end, and from in-queued time. From start processes all historical events, while from end starts from the latest events. From in-queued time specifies an exact timestamp for starting position. Configuration is done in function JSON or Event Hub trigger attribute and is useful for catch-up processing. 18. Explain Event Hub's trigger retry behavior. Event Hub's trigger does not have built-in retry, so failures prevent checkpoint advancement. Message reprocessing occurs on the next invocation after failure or instance restart. Implement custom retry logic inside the function for transient failures. Use poison message pattern to move failed events after maximum attempts. 19. How do you monitor Event Hub's throughput? Azure Monitor metrics provide incoming messages, outgoing messages, throughput, and errors for the Event Hub's namespace. Application Insights tracks function invocation count, duration, and failures for Event Hub's triggers. Event Hub's partition metrics show per partition throughput and processing lag. Set alerts on high backlog or processing latency. 20. What is the role of Event Processor Host? Event Processor Host is the legacy library underlying Event Hub's trigger for checkpointing and partition distribution. It manages lease acquisition, checkpointing to storage, and load balancing across instances. It has been replaced by newer Event Processor Client in modern software development kits but is still used internally. It ensures reliable and ordered processing per partition. 21. How do you handle event deserialization? Event Hub's trigger receives event data with binary body, and it is deserialized using JSON.NET or system text JSON. Use strongly typed models with Event Hub trigger binding for automatic deserialization. Handle schema evolution using flexible deserialization or versioned payloads. Validate deserialized data before processing to prevent errors. 22. Explain Event Hub's trigger in isolated worker model. The isolated worker model fully supports Event Hub's triggers with the same configuration and behavior. The worker process handles event processing independently for better isolation. It provides improved dependency management and language flexibility with .NET 8 and above. Configuration via host, JSON and application settings remains consistent. 23. How do you secure Event Hub's connections? Prefer managed identities or shared access signature tokens instead of connection strings for secure access. Use private endpoints to secure the Event Hub's namespace within the virtual network. Restrict the Event Hub's firewall to allow only function app outbound traffic. Assign least privilege roles such as Azure Event Hub's data receiver to the identity. 24. How do you test Event Hub's triggers? Use Azure Portal Test Event feature or Software Development Kit to send test events to Event Hub. Perform local development using Event Hub's emulator or real namespace for trigger testing. Run the function using func start and debug with breakpoints. Integration tests validate checkpointing and partition handling. 25. Best practices for Event Hub's trigger usage. Use a unique consumer group per function app to avoid checkpoint conflicts. Implement idempotency and proper checkpointing for reliable processing. Tune batch size and concurrency for the best balance between throughput and latency. Monitor throughput, processing lag, and failures, and set alerts on high backlog or errors. Thank you for watching. If this video helped you prepare for your Azure Functions interview, please give it a thumbs up and share it with your network. Do not forget to subscribe to ZoomInData and hit the bell icon for more in-depth cloud computing, serverless, and Azure interview preparation videos every week. Drop your questions or topic requests in the comments. Let us zoom in on your success together.